All right, we open up to the next clean page in our math notebooks. We are starting a new unit this week. Last week we did a bit of a review with graphing ordered pairs and noticing patterns in tables. Today we are getting started on topic 13, which is the order of operations. Raise your hand if you've heard order of operations before. Okay, a few people have heard the term before. Okay, so first we're going to title the top of our page 13.1 order of operations, and then today's date, which is 3/8/21. Now you might be wondering, like, okay, Miss E, what do you mean by order of operations? What does that mean? Well, we know in math, our operations are the things we do with our numbers. So we can add them, we can subtract them, we can multiply them, and we can divide them. Those are our operations. However, there are going to come times, like in this unit, when we are given an equation or an expression that has multiple numbers and multiple operations in them, and we need to know, what order do I solve these in? So we are going through kind of like the rules. If you're given an equation that has like addition and division and multiplication, and then there's something in parentheses, we are going to discuss what order we should be following, because if there was no order of operations, people could solve equations in a different order and get different answers, and then how would we know who was correct? So these order of operations are rules that everyone follows for math. These are rules you will be using in math through high school, and if you go to college, in college. So we start learning about them now so that you're ready for middle school, high school, and if you end up going to college. Quickly, Emmy. So the first thing, and even if you don't go to college, if you're in some sort of trade and you're having to use math, if you become an architect, if you are building anything like that, you use math. So you still need to know these. So the first thing we always keep in mind, just like with when we read something, we always work left to right. Always work left to right. So if you have two addition symbols, for example, in a problem, you would solve the first one on the left, and then you would solve the one to the right. So we always work from the left to the right. If it's helpful to you, if you're someone who has a hard time figuring out, okay, which way is left, which way is right, what I would sometimes have students do is on like your homework page or whatever it is, put an L up on the top left of your paper, and put an R on the top right of your paper. And you can do that right now in your notebook too. An L on the top left, an R on the top right. That way you can look up and you always remember where the left is, where the right is. I know some of you do this trick, which one's the L, but by writing it, then you don't have to do that for every single problem. Addie?
I know, I just remember I write with my right hand, so
Oh,
this is the right side.
yep. Yep, that's another way. So if you're someone who has a hard time, Jack, if you're someone who has a hard time figuring out left from right, I would put an L at the top left and an R at the top right of your paper. So we use an acronym to remember the order of our operations. Who can remind me what's an acronym? We used one when we were dividing fractions. What's an acronym, Philip?
Oh, the thing that makes it shorter, like W-N-T.
Yes, so it's like an abbreviation using letters, and each letter stands for something, right? So we use Pemdas, P-E-M-D-A-S. I always remember it as, please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. So that order, P-E-M-D-A-S, that tells us the order of our operations. And we are going to write down PEMDAS right now. So the first one, the P, please, stands for parentheses. Yeah? The P in PEMDAS stands for parentheses. So that means, since P is the first letter in PEMDAS, if you look at an equation and there's anything in parentheses, you solve that first. Now, there are three different types of parentheses you might see. One is called braces, and with that, you do a curve, a point, and then another curve. See how there's like a point between the two curves?
So like a 3?
Almost like a 3, but you're adding in a point. So you do a curve like the top of a 3, then you come out and make a point, and then you do the bottom curve. So it's like curve, point, curve. We call those braces. Then we have brackets, which it's kind of like if you took a parentheses, the curved ones, and you just straighten them all out, it's a bracket. So it's like half of a rectangle. Each half. Yep. And then parentheses, these are the ones we're most familiar with. They're the curved ones that we know. So we use these three. We'll be learning more or dealing more with like braces and brackets tomorrow. Today we'll mainly work with parentheses. So you don't need to quite worry about braces and brackets yet, but get them written down so you know what we call them. If I say, solve what's in the brackets first, you want to know which one I'm talking about. Addie?
I know. Last year, Mrs. Wells had us Pemdas made it for school.
Mm-hmm. It's similar, except we add in the E in 5th grade. Yep, so Pemdas may destroy a school. That would be PMDAS. Yep, and in 5th grade, we do Pemdas. Please excuse, there's an E, my dear Aunt Sally. Nice. But you can definitely use that to help you with this as well. So give me a thumbs up when you have parentheses written down. And my P in parentheses is pink. Awesome. Thank you. That's why we use acronyms and sayings. It's easier to remember that way. Yeah. Thank you. Give you another moment. Very quickly. So you should be turned around in your seat, not talking to the people around you or making noises to the people around you. You need a point in between the two curves. So it should curve, point, curve. So if you look at mine, see how there's a point there in here? Yep. I see. Yeah, feel better. All right. So parentheses. So please. Then we have the E, excuse. Does anyone think they know what the E might stand for in PEMDAS? What do you think? Addie? Not expand.
Oh, what is it? It's not like 2 if you range it. What is it? I can't remember the name.
Exponents. Yes. So, next up, we have an equation. Let's say we solve what was ever in parentheses first. Then we have something that has an exponent. Remember, an exponent is that little number we put at the top right of another number, excuse me. So what that tells us, so here I have x and then to the 3rd power. That means we're taking x 3 times. X times x times x. Now, if I have 2 to the 3rd power, then we're taking 2 times 2 times 2. So that's always the second step. These are orange, kind of. Yes, Layla. I'm really happy you asked that. So do you guys notice how when I was multiplying my x's, I put a dot instead of our cross or our x for multiplication? Does anyone know why I did that? Why would I do that? Well?
Because there's already an x grade.
So 5th grade, when you get into higher math classes, you are going to start using variables more. And a variable is a letter that we see in an equation that stands for a number. X is used a lot as a variable. Now, if we're using x's as variables and then we're using an x as a multiplication sign, could it get confusing to figure out which is the multiplication sign and which is the variable? Yes. So when you get more into algebra, where you're using variables, you will start using a dot in like the middle of your lines as the multiplication sign instead of an X. So I was hoping someone would ask me about that. So Layla, thank you for asking that. But then up here, when I was using all numbers again, I used the X's again for multiplication. So this way, it's like a little preview. You can just kind of see how it's used. What?
Isn't it also used for
I mean, it's not really too cumbersome to write a little X versus a little dot. All right. So we have our exponents. What's the next letter in Pemdas? What's the next letter? What's the next letter? Raise your hand. Michael.
M?
M. Who can raise their hand? What do you think the M stands for? What does M stand for, Chanel? Multiplication. Now, I'm not going to show you multiplication until you also tell me what comes after the M in PEMDAS. What comes after the M, Elena? D. And what does the D stand for, Frankie? Division. The reason why I wanted to talk about the M and the D stand for is they are kind of grouped together when it comes to our order of operations. So I'm going to show you both of them. You can take your time. So here is M and D. Now you'll notice I wrote them separately. However, I have an or here. The reason why I have an or here is because when we are following the order of operations, remember we work from left to right. It doesn't matter which one comes first. If you have a multiplication sign first or a division sign, you work on all of them together left to right. So first, always work left to right. It does not matter which one comes first. So I will zoom in on the two examples. Give me a thumbs up when you have multiply or divide written down, and then you have the always work left to right and does not matter which comes first. Give me a thumbs up when you have that down, and then I can zoom in on the examples. Yep, so when you have this and this written down, give me a thumbs up, and then I will zoom in on these two. Yep. Yep. Yeah, just get these. Thank you for giving me a thumbs up, Will. Thank you, Michael. Thank you, Emmy. Thank you, Zoe. Please sit up. Thank you, Senna and Allison. Thank you, Chanel and Grayson. Thank you, Mackenzie. Thank you, Eosius. Thank you, Philip. Thank you, Layla. Now, I will let you guys know, when we start doing this, you're going to look at the problem and go, oh my gosh, that is so much work. It really isn't. Because of PEMDAS, when we get used to knowing the order that we solve these equations in, you really get the hang of it. And that's why it's one of my favorite things to do, is because you guys will look at a problem and think, oh my gosh, this is going to be terrible. But then by the end of it, when you've gone through and solved each step, you're usually very proud of yourself. And it's kind of fun, figuring out, okay, which one do I do first? And then what do I do next? Awesome. Kind of like a little formula. How to do. When I zoom in on it, you can. Thank you, Addie. All right. Can I zoom in on the examples? Is there anyone who needs more time? Okay. So, to go with these are two examples. Right here. So, let me move it. There we go. Okay. Example 1 and example 2. So in example 1, you can see I have an equation that has 2 times 3 plus 4 divided by 2. In this example, we have multiplication and division. So I work left to right. I would complete 2 times 3 first. Then I would come over and complete 4 divided by 2. However, in example 2, my equation is 6 divided by 3 minus 2 times 1. So 5th grade, should I come over and solve this multiplication problem on the right first? No. It doesn't matter which one's first. You just need to make sure you work left to right. So on the left in example 2, I have the division problem, so I would solve that first. Then I would come over to the right and I would solve the multiplication problem, 2 times 1. So it doesn't matter which one comes first. Okay. So it doesn't matter which one comes first. You solve the one on the left first, then on the right. No. Oh, that's okay.
It's like a bingo. You know when they shuffle bingo balls?
Yeah.
And I wasn't looking. I was like, oh, she's got a Hey, would you like a next one or a head snap? There you go.
Nice.
Thank you.
Thank you, Mrs. Roach. So does anyone have questions on the multiplying and dividing of order of operations? Does it make sense that it doesn't matter which one comes first, you solve from left to right? Does that make sense? Okay. Make sure you are writing down the examples. Make sure you're writing them down. So give me a thumbs up when you're both written down. Awesome. Awesome. Thank you. I see a few more people. Finishing up. Thank you. So with multiplication and division, it doesn't matter which one comes first. You just solve the one on the left first, then the right. Solve the one on the left first, then the right. We work left to right. Thank you. Thank you. So our acronym is Pemdas. We've gone over P parentheses, E for exponents, M for multiply, and D for divide. What do you think the last 2 steps will be in Pemdas? What will our last 2 steps be? Jack?
No, it's not on this, but when are there's some 2 last. What are they called?
Order of operations?
Yeah, order of operations. Are those or those done?
We have 2 practice problems. Yeah? Yeah, I'm excited to practice them. What do you think our last 2 will be, Richie?
Add and subtract.
How many of you agree with Richie? Awesome. Add and subtract. Are we ready to go on to add and subtract?
Yeah.
Okay, let me zoom this back out. So, just like with multiply and divide, 5th grade, add and subtract are grouped together. So once we're done multiplying and dividing anything we can, then our last step is to add and subtract. So, add and subtract. I'm going to scoot this up. Yep, add or subtract. So again, you always work, Jackie, you always work left to right. It does not matter which comes first. And we have the 2 examples again. And I'll zoom in on those when we're ready. So give me a thumbs up when you have add or subtract. Always work left to right, and does not matter which comes first. Then I'll zoom in on the examples. So add or subtract. So really, even though we have 6 letters in Pemdas, we really only have 4 steps because we do parentheses first, if there are any. If there are exponents, we would do those second. Then our 3rd step is multiplication or division. We do those in the same step and we work left to right. Then our 4th and final step is to add or subtract. Left to right, doesn't matter which one comes first. So really, even though there are 6 letters in Pemdas, or please excuse my dear Aunt Sally, we really only have 4 steps because multiply and divide is step 3 together. And then add and subtract is step 4 together. Thank you, Will, for giving me a thumbs up. Thank you, Layla. Thank you, Sana. Thank you, Emmy. Thank you, Mackenzie. Thank you, Addie. Thank you, Michael. Thank you, Richie. Thank you, Zoe. Thank you, Josias. Thank you, Allison. Thank you, Grayson. Give you another moment or so. You guys are doing great today. Yes, Layla. Oh, we have 2 equations we're going to solve. We'll do the first one together, and then you guys will be able to do the second one on your own. Okay, are we ready for the examples? Yes? And make sure you are circling or underlining the word not, and does not matter which comes first. I also do that with multiply and divide, so make sure the not in that one is also circled or underlined. All right, so examples. Here are our examples. We have example 1 and example 2. So, for example 1, my equation is 2 plus 15 minus 5. So I have addition and subtraction. Well, it doesn't matter which one comes first, so I just work left to right. So I would do 2 plus 15, then I would do whatever that is minus 5. Then in example 2, I have 7 minus 2 plus 5. So in this one, the subtraction comes before the addition. That doesn't matter. I still work left to right. So I would do 7 minus 2, get that answer first, then add it to 5. So I always work left to right. Give me a thumbs up when you have the 2 examples written down. All right. And I circled the addition symbols in blue and the subtraction symbols in purple. That's why they're circled. Thank you for giving me a thumbs up when you're ready. Thank you for not turning around in your seat and just kind of waiting. I appreciate that. Thank you. Thank you. Thank you. I have 1 more minute to get these down. Thank you. Thank you. Okay. Mm-hmm. Oh, yeah, you're right. All right, we ready? Anyone need more time? Okay, taking it as a no. Okay, so before we do our practice problems, this is what we have, right? This is what we have. So, technically, how many steps do we have here? Show me on your hand. Technically, how many steps do we have here? Technically, how many steps do we have here? I know we have 6 letters, but how many steps? Technically, we have 4 steps. because multiply and divide is grouped together and add and subtract is grouped together. So let's label them. So next to parentheses, let's put a 1. Next to exponents, let's put a 2. Then next to multiply or divide, let's put a 3. So notice I'm putting it right between them. Then next to add or subtract, right between them, let's put a 4. This 5th grade, even though multiply has its own letter, divide has its own letter, same with add and subtract, I want you to think of multiply and divide as the same step. And then I want you to think of add or subtract as the same step. So we have 1, 2, 3, 4 steps. Do we have our steps numbered? 5th grade, do we have them numbered? Yes. All right. Does anyone need more time? Okay, so practice. We're going to have 2 practice problems. And we are going to work on the first one together. And then I will let you do the second one on your own. So again, it's going to look like, oh my gosh, Missy. But we follow our Pemdas, our please excuse my dear Aunt Sally. We will be able to get it. So I covered up number 2. Here's number 1. Yep. You can say it's easy all you want, but that's your opinion. Let's get it written down, please. So number 1. Our equation is 12 divided by 4 plus, then in parentheses I have 9 minus 2, times, then in another set of parentheses I have 3 plus 5. So give me a thumbs up when you have this written down. Give me a thumbs up when you have this written down. Perfect. Thank you. Eosis, do you have a question?
Yeah, okay. Do brackets mean different or
Sometimes, when we're going to see this tomorrow, sometimes you may have on the outside of an equation braces. And then a little bit further in, you have certain things around brackets. And then even more inside, you have parentheses. So we're going to talk about, okay, when we have all 3, and like there's brackets within braces and parentheses within brackets, what do we solve first? So we'll be getting into that tomorrow. Today, if you see parentheses, they will be the parentheses you know, the curved ones. Mm-hmm. What's up? Go ahead. Yes, Zoe? No, we won't be solving it until we get a little further down our page. Okay? All right. Do we have our practice problem written down? Okay. We'll quickly get it written down. Everyone else who has it written down, I want you to think about what our first step will be. Don't actually solve it yet. Just think about what it will be. Think about what it will be. Frankie, do you have a question?
Yeah.
Okay.
It's about the problem. So,
okay.
Which one would come first? Which set of parentheses?
We're going to talk about that. I hear some people saying it. Yep. So, Frankie asked a really good question. Now, we know in our order of operations, Pemdas, the P comes first for parentheses. Well, we have 2 sets of parentheses, right? How do we know which one to do first? Raise your hand. How do we know which one to do first? How do we know which one to do first? Allison? We always work left to right. So step 1, parentheses, we would solve what's in the left parentheses first. So if I do that, what is 9 minus 2? It is 7. So okay, how do I want to show this? Put an arrow. 7. Now that I've solved that one, now I can solve my right one, right? Okay? Because this is all one step, but we're working left to right. What's 3 plus 5? 8. Then, okay, so I've completed the first step of Pemdas. Now I need to bring down everything else. So I looked through my whole problem. I can get rid of the parentheses now that I solved what was in them. So I'm just going to bring down my multiplication symbol, the addition symbol, the 4, the division symbol, and the 12. So, P for PEMDAS, or for parentheses, excuse me. We've completed that. What's the next step here? First of all, do we have any exponents? No. So we can skip step 2. What is step 3? What is step 3, Mackenzie? I'm so happy you said multiply or divide, and divide. Remember, they're grouped together. Now, do we have more than one multiplication and division sign here? We do. We have a division symbol and a multiplication symbol. Raise your hand. How do I know which one to do first? Elena. Always work left to right. So, what I solve, put your hands up if that means I solved the multiplication symbol first. Okay, put your hands up if that means I solved the division. Yes, the division problem first. So, what is 12 divided by 4? It is 3. So 12 divided by 4 is 3. Bring down my 3. Then I can come over to the right and I can solve the multiplication. What is 7 times 8? What is 7 times 8? Layla? Do we agree with Layla? Yes. 56. So, solve the division and the multiplication. Now I bring down that plus sign. So then what's my fourth and final step, 5th grade? Who can raise their hand and tell me? What's the fourth and final step? Drew? Can you please tell me the fourth and final step? What did you label number 4 in PEMDAS? I'm asking Drew. What is it, Drew? And? Yep, adding and subtracting. So do we have more than one addition and subtraction here? No, I just have the one. 3 plus 56, which is 59. Now, 5th grade, I want you to imagine for a second we didn't have PEMDAS. How many different ways could someone solve this? Lots. They could start with division. They could start with adding. They could start with multiplying. There are so many different ways people could solve this, right? So, by following PEMDAS, please excuse my dear Aunt Sally, we can make sure we're getting the same answer when we are given a multi-step equation like this. Richie.
So, you solve the parentheses first, always? Then I'm a little confused because you said only solve left to right. I did it dividing.
So that's why we solved it together. But also, Richie, within each step, you solve left to right. So step 1 is parentheses. So we would solve multiple sets of parentheses from left to right. Then we go on to the exponent step. And if you had more than one exponent, you would solve the exponents left to right. Does that make sense? So you work left to right within each step. What questions do you have? Do you have a question, Jack? Elena.
Are we going to have any exponents in the next practice?
Not in the next practice problem, no. Jack P., please go back to your desk. Will
we have exponents in our homework?
Not today, no. Okay. Are you guys ready for the practice problem I'd like you to try on your own? Okay. Make sure you're going step by step and you're working left to right within each step. Here's the one you are doing on your own. Even if you want to come ask me a question, I would like you to really try to solve this one on your own because I want you to get used to it. We will solve it together, of course, at the end. But until then, I'd really like you to try to do this one on your own. So here's number 2. Here's number 2. Voices off. Guys. So for number 2, in parentheses, Jeff P., take a seat so the people behind you can see. In number 2, we have 15.3 minus 12. Then outside of the parentheses, I have plus 2.5 times 2. Now, when we are adding decimals, what always needs to line up? When we're adding or subtracting decimal numbers, what always needs to line up? Mackenzie? The decimal point. Do we need to make sure they line up when we're multiplying or dividing? No. Okay, I'd like you to go ahead and try and solve this one on your own using the steps of Pemdas, or order of operations steps. Just set it as a class. When you're adding or subtracting decimals, you need to make sure the decimals line up when you stack them to add or subtract. But when you're multiplying or dividing, you do not line up your decimals. You line them up just like a normal multiplication problem. And if you're still using the first notebook you got for this year, you guys, your division notes, or your decimal notes should be at the front, towards the front of your notes too. Just a reminder. Maybe another minute or so. Try and solve this on your own. Of course, we're going to look at it together. And you can see which steps you did in the correct order, and if there are any steps that maybe you did before you were supposed to do. What are your order of operations, though? Do you skip all the way back to adding? No. Thank you to those of you who are quietly waiting. I love that I see some people looking back over their steps after they solved, making sure, okay, did I solve what was in parentheses first, then exponents if there are any, then multiply and divide, and then finally add and subtract. I love that people are going back and looking over their steps. All right, ready to rock? Okay, let's look at this together, 5th grade. If you are reading a book, please put it away. If you are writing on something else or drawing or anything like that, please put it to the side. Okay, now I'm zoomed in, so you guys can't see my steps up on the board, so I'm just off to the right. I'm going to write a reminder to myself. Please excuse my dear Aunt Sally, Pemdas. You guys, is there any rule that says you can't write Pemdas like off to the side of your homework or the side of a test? No. Write it. Pemdas. And then you know what else I'm going to write? I'm going to write left to right. Is there any rule that says you can't write that down on your homework or a test? No. This is not cheating. This is remembering an acronym that will help you be successful and help you succeed. So PEMDAS, left to right. So looking at this, let me grab one of my pens. I'll grab this one. When I'm looking at this, P stands for parentheses. Do we have parentheses in this? Yes, right here, right? Okay, so I know that I need to solve that first, so I'm going to put my arrow down. However, maybe I can't do this in my head. Maybe I need to go off to the side and complete it. So I'm going to come down here. I have 15.3 minus 12. So 15.3. Now, I have the whole number 12. Where is that imaginary decimal point in 12 fifth grade? It's a whole number, so where is that decimal point? Michael? Right after the 2. So that means my 1 is in the tens place, my 2's in the ones place, yep. So I'm going to put the imaginary decimal actually there and then fill in any gaps. So that would be here. Now I can subtract. 3 minus 0 is 3. 5 minus 2 is 3. 1 minus 1 is. How do I know where the decimal goes? I bring it all the way down. I'm going to scoop this up for a second just so you can see my work. So that means 15.3 minus 12 is actually 3.3. Awesome. Now, fifth grade, do I have any other parentheses in this problem? I don't. So I'm going to go ahead and just rewrite the rest of the problem. So I still have my addition symbol. I still have 2.5. I still have my multiplication symbol, and I still have 2. Now, Pemdas, what would come next? What would come next? Richie? Exactly. There are no exponents here. So, multiplication and division. In fifth grade, when you write out Pemdas, I just forgot to do this. I like to go like this, just to remind myself that we group them together. I like to do that. I completely forgot to do that. Okay, so multiply and divide. Now, I just have one multiply or divide symbol, right? Okay, so that means I need to now multiply 2.5 times 2, right? Okay, now let's say I can't do this one in my head. I need to set up a problem, a multiplication problem. So I would take 2.5, put my multiplication symbol, and does the 2 need to line up with the ones place here? No. When we multiply decimals, we just write them the way we normally would, as if the decimal's not there. So 2 times 5 is 10. 2 times 2 is, plus 1 is 5. All right, so my answer is 50. What am I missing? Decimal. How do I figure out where to put the decimal? Nope, I don't bring it down. That might work for this one, but that's not how it works. How does it work? Who remembers? Who remembers? Whisper to the person next to you. How do I know where to put the decimal in a multiplication problem? If you can hear me clap once. If you can hear me clap twice. Who can raise their hand and tell me? You don't just drop it down. It might work for this one, but that's not how we figure it out. How do we figure it out, Will?
How much numbers are to the right of the decimal?
How many numbers are to the right of the decimal and the 2 numbers we're multiplying? We only have one decimal number here, and we have just the 5 to the right of the decimal. So that means I need just one digit to the right of the decimal in my answer, excuse me. So I put the decimal there. And this one, it looks like we're just dropping it down, but that's not what we're actually doing. So 5. So my 2.5 times 2 actually gets me 5. And then I need to bring down, I still have the addition symbol. And even though I still have 3.3, I still need to bring it down, because I haven't done anything with the 3.3 yet. So now I have 3.3 plus 5. Raise your hand if you can tell me what 3.3 plus 5 equals. What does 3.3 plus 5 equal? Whisper to the person next to you. What does it equal? Jack P., whisper to the person behind you. So 3.3 plus 5 equals what? On the count of 3, tell me. 1, 2, 3. 8.3. We add the 5 in the ones place to the 3 that's in the ones place. That gets us 8. We still have 0.3 afterwards. So 8.3. Now, 5th grade. Ignoring the actual, like the decimals, how many of you understand the steps we take? You do parentheses, then if there are exponents, you do exponents, then multiply and divide, then add and subtract. How many of you understand that part of this? You understand that part of this? Okay? How many of you, Drew, sit up please. How many of you were getting a little turned around with the decimals? Please be honest. How many of you were getting a little turned around with the decimals? Okay. Now, 5th grade, does one skill, just because we worked on decimals at the beginning of the year, does that mean we just stop working with them for the rest of the year? No. So I suggest, if you were getting tripped up by those simple addition and subtraction problems with decimals, please look back in your notes. Most of you are still on the first math notebook, so that means you have the notes from our adding, subtracting, multiplying, and dividing of decimals units. Please look back at them. Because Pemdas works with any numbers in math. It's just the order we do them in. So there could be fractions that we just got done working with. There could be decimals. There could be whole numbers. So make sure you are looking back at your notes. Capiche? Okay. So what I would like you to do is take out your math workbook. Please open up to page 739. 739. Do we need to talk in order to open a workbook? No, we do not. 739. You are circling numbers 1 through 5. So 1, 2, 3, 4, 5. 1 through 5. Number 14. Number 14. Then number 18 through 20. So 18, 19, 20. 18, 19, 20. Now 5th grade, I'll repeat it one more time, and then I have a note. So please stop talking and please listen. First I'm going to repeat it. Page 739. You are circling numbers 1 through 5. So 1 through 5. Then number 14. And numbers 18 through 20. So 1 through 5, 14, and 18 through 20. Now 5th grade numbers 1 through 5, that's what we were just working on. Solving these equations using the order of operations. Number 14, however, what does it ask you to do for number 14? What does it ask you to do, Richie?
Well, 14 and 18.
Yep. Oh, yeah.
You put the parentheses around it to make it true.
Yes. So they give you an equation and the answer, and you need to figure out what part would you need to put parentheses around in order to make it true. So basically it's asking you, which part do you have to solve first in order to get the answer that they give you? Does that make sense? Mm-hmm. It's kind of like if you had 3 plus something minus something else, but someone needed to solve the subtraction part first in order to get the correct answer, you would put parentheses around the subtraction part. So for 14 and 18, they give you the answer. You just need to figure out where do you put the parentheses, or what does someone need to solve first in order to get that answer. Capiche? Okay. I'd like you to go ahead, start on this. Keep your notebook open so that you have the order of operations right in front of you. I will turn on work music.